All right, welcome to chapter 2, which is about solving equations. We're jumping right into the middle of chapter 2. My opinion, some of this early stuff is very simple, so we're going to just kind of breeze through it pretty quickly and just do what I think it should be a little bit of review. So first thing, our goal of this chapter is to focus a lot on solving equations and what does it mean to actually solve an equation. We could go with book definition, but solving an equation by bringing up an equation here might help us. Solving an equation means basically finding the value of the variable, that makes the statement true. Makes the statement true. Makes your equation true. So when I'm looking at solving an equation, I really think kind of unofficially, what does solving mean? It means get the variable alone. Get x or y or whatever variable it happens to be. Get that all by itself so that your equation reads x equals, and then you have the number on the other side. So you can think of it unofficially or officially, but the idea is the same in both cases. So hopefully you tried the applet and kind of got an idea of this idea of basic one-step equations, or that you remember from previous courses about solving one-step equations. So the idea, and this is the basis for solving any equation, is if you want to get the variable all by itself, you need to use opposite operations. So I'll star that and write that. We need to think opposite operations, or in other words, this idea of undoing operations. So to get x all by itself, what's causing the problem? Well, this addition of 5. So we want to get x all by itself so that we know what x is equal to. So to do that, we do the opposite operations on both sides of the equal sign. I know that on some of these problems, especially this first page, you're going to see the problem and most of you are going to say, oh, I know what the answer is already. And I really want to emphasize for these even easier problems, it's really going to help you at this point to get used to writing out your steps, working out the problem, and making sure you're organized. So like, for instance, I just drew that line down the equal sign. That really helps you keep it track what's on the left side of your equal sign and what's on your right side. It's very important to stay organized with these. So positive 5 and negative 5 equal to 0, or positive 5 minus 5 is equal to 0. So this actually cancels out. So what am I left with on the left side? Just x equals, and on the right side, if I solve that, simplify it, I get my solution. So that's the basic idea of solving an equation. So we look at one-step equations, and I've got 3 other ones here. It's just the idea of doing the opposite operation. So if I see multiplication on both sides, so equality to maintain equality, if you think of it as a kind of a balance. If I divide by negative 3 on one side, I've got to divide by negative 3 on the other side to maintain that equality. So x is equal to negative 4. If I see division, the opposite would be multiplication. So to undo that division, cancel that out. I multiply by 6 on both sides. And for instance, to get this x alone, it may not always be obvious what the opposite operation is, but you want to think, what am I trying to do? I'm trying to get rid of this 3. I want to get x all by itself. So to get rid of 3, I'm going to add 3 to both sides. X equals 7. So just kind of a little review of one-step equations, but what we're really concerned with is two-step, and even more so concerned with multi-step. So I'm going to do a two-step equation just to kind of get you back into the groove of these, and hopefully you've seen these before, but if not, remember our main idea is to try and get the variable alone. We want to know what x is, or in this case we want to know what a is. So to figure out what a is, what's causing us problems? Well, this plus 10 is causing us a problem, this 4 is causing us a problem. We know we want to use opposite operations. The other thing that's important, just like when we're doing operations normally, is what order do they need to go in. So this is not and I'll write up PEMDAS, but GEMS would also work. This is not a 100% of the time, but it is kind of a guideline. Just like PEMDAS, you kind of have to use a little bit of extra thought. It's not just go to the parentheses and do something to the parentheses. You have to use some extra thought. When we're doing solving, you're thinking about it as its opposite. So we're undoing all these operations. So if you want to think about it, here's a good analogy. If you're getting dressed in the morning, you're putting on your shoes. So I'll just write this on. You put on your shoes. Put on your shoes. What do you do first? You probably put on your socks. And then step 2 is to put on the shoes. Put on your socks. Put on your shoes. So if we think about that as doing an equation normally, plugging a number in for x or plugging a number in for a. If we take off the shoes, that's undoing the operation that we did. That's undoing the putting the shoes on. Think about what step 1 is. You can't just take off the socks first. What do you have to do? You have to do the opposite operation, and you have to do it in the opposite order. You have to take off your shoes, either one at a time or both of them, and then you can take off your socks. So when we think about the order of operations, it actually needs to be in opposite order. So opposite order. So for our problem that we see here, if I plugged a number into A, if I think what operation would happen first? Well, PEMDAS says multiply by 4, then add 10. So if I'm going in reverse order and I'm undoing these operations, I need to undo the 10, the addition of 10 first. How do I undo addition of 10? I subtract 10. So we're going opposite order, opposite operations as far as solving goes. So this 10s cancel out. I'm left with 4a because nothing happened to the 4a. And then on the left side, 18 minus 10 is 8. I've only got a one-step problem left, and so I divide by 4 to undo the multiplication by 4. The 4's cancel. I'm left with 1a, or just a, and a is equal to 2. What I want you to keep in mind is, notice, and this is the nice thing about the quiz that we'll take on this topic, is you can check your answer. You should be able to hand in your quiz and know 100% whether you got all of them right, whether you got some of them wrong, which ones you got right, which ones you got wrong, because you can check your answer. So don't forget, how can we check our answer here? Well, if I take that 2 and plug it back in for A, 18 equals, if I did the problem correctly and I simplify correctly, I should get a true statement. So checking your answer is an important part. I'm going to mention it here. I'm probably not going to mention it on the rest of the problems, but it's an important skill, and I'll mention it a lot in class. So here's your you do. You try solving the two-step equations. Remember, think about putting the socks on, putting the shoes on. How would you undo that? It's the same idea for undoing operations in the equation. So if I plug something in for n, what would happen first? Well, we'd divide by 7. Then we'd add 2. So if we're going to undo, we need to go the opposite order. So first thing is, and I'm going to divide my page down the middle here, I'm going to subtract 2 from both sides. The 2's cancel out. N over 7, nothing happened to it. And I'm going to do 10 minus 2 is 8. How do I undo the next operation? Well, it's division, so I'm going to multiply to undo. N is equal to, and 7 times 8 is 56. So those are your basic two-step equations. Pretty straightforward. We'll talk about some exceptions in class and working with them in class, but keeping in mind those steps, I want you to try one more you do, which involves solving the same type of equation. If you look at what operations do you see? I see division by 8, and I see that I'm subtracting 3/4. Even though I'm using fractions here, this is the same process. It's the same two-step equation. So pause, try the problem. So how do I solve this? Well, I'm going to undo the subtraction by 3/4 by adding 3/4. So 7/12 plus 3/4 is the problem. 7/12 plus, this is 9/12. So that's 16/12. So if I write my next line, y/8, nothing happened to y/8, equals 16/12. Now how, so those canceled. How do I undo that? I'm going to multiply by 8, which is 8/1. And I'm going to cross cancel, simplify. Both of 12 and 8 can be divided by 4, so that's 3, and that's 2. So my final answer, the 8's cancel out. Y equals 16 times 2 is 32. 3 times 1 is 3. So 32/3 is an acceptable answer, or if you want to put 10 2/3, either one will work. We're going to stop here with just these two-step equations, 1 and 2-step. We'll practice some in class, and then we'll get into some more complicated equations. Multi-step is what we'll call them. At this point, we're only doing 2 steps. We'll throw in some fractions to make sure you're reviewing that. But until then, 1 and 2-step equations are what you should feel semi-comfortable with at this point.